Once you enter Fusion, go to Manufacturing at the top, where you'll find the Tool Library icon. Click on it, and the first thing we need to do is create a tool holder that matches our machine's holder. In Fusion, there are many pre-made industrial scale holders used on professional machines. But unfortunately, my machine is not of that type. Why do we make a custom holder? We make it so that we have fewer issues later with heights and feeds during machining. If we work without a holder and the program decides the end mill cannot execute the operation due to these clearance issues, it will throw an error. Great, we've made our tool holder, and now it's time to create the end mill itself. We click the plus button and select the type of end mill we want to create. In this case, we are making a 3mm end mill for PCBs, but we'll use it for various purposes. The cutting part and the shank are the same dimension. It is also very important whether your end mill is left-handed or right-handed. In most cases, right-handed end mills are used on home machines because the spindle can't even rotate to the left. Exact dimensions aren't printed on most end mills, so it's recommended to measure your end mill yourself. This includes the total length, the length sticking out of the holder, both non-cutting and cutting parts, and the cutting part itself. Why is this important? For end mills where the cutting and non-cutting parts differ, if the upper non-cutting shank is wider than the cutting part, the program automatically tells you that the end mill cannot cut deeper than the length of the cutting part. However, if the cutting part has the same dimension as the shank, machining will be allowed in multiple passes, as long as a single pass depth doesn't exceed the cutting length. We will also attach our tool holder to the end mill. And now we have a clear picture of what the end mill actually looks like in the real world. Now we will set our milling speeds, meaning the spindle speed, the feed rate for entering and exiting the material, and the cutting feed rate itself. I must point out here that a lot of experience is needed because everything depends on the material and the type of end mill you have. I think you'll spend quite a bit of time on this optimization until you figure out how your machine behaves with specific tools and materials. But I still hope you'll master this successfully. In the title, I'll write that the process is easy so that as many people as possible see this video and solve their problem. But you'll see that it's actually not easy. Also keep in mind how your end mills are cooled, whether it's water, air, or something else. This matters because some machines have built-in sensors for air and water release. And if you don't have that option, you need to set it to disabled to avoid G-code errors later. Finally, pay attention to the tool change option you use. Whether it's an automatic tool changer or you change the end mill manually, you must pay close attention to this, otherwise you'll run into G-code errors as well. I hope this tutorial helped you, and I'll see you in the next video.